Well, on this video, we'll be discussing the tangent ratio. So let's start by looking at this introduction question, which states, here we have two triangles, ABC and RST. And now the question is there any relationship between angle IA and angle R? But the only thing that we know so far is that we have two similar triangles. And recall that when we have similar triangles, corresponding angles will always be congruent. So therefore, angle A is corresponding to R, so therefore they must be congruent. Angle C is definitely corresponding to T. They're definitely congruent. They're both 90 degrees. And also, we can see that angle P, or angle B, I'm sorry, is congruent to angle S. It should be a B here. So now the question is there any relationship between angle A and angle R? Well, we know that they're part of similar triangles. They're the corresponding angles. So therefore, angle A must be congruent to angle R. Now, since we know that those two triangles are similar, can we write down the proportions among line segments of ABC and RST? Well, we know that they are similar to each other, so therefore, A over C, AC over RT, AC over RT, that should be equivalent to BC over ST, BC over ST, which is also similar to BA over SR. And the reason why we have this is because we know that they are similar triangles and therefore their proportions must be equivalent to each other. So let's just put this idea on the side because we're going to come back to it, and let's actually state the tangent ratio. So what do we mean by the tangent ratio? Well, a tangent, it's a function. We're going to consider tangent as being a function. And but what kind of a function? Well, let's see. Take in consideration the triangle on the right hand side, we can write down a ratio to define the tangent of an angle. Well, tangent, it's a function, supposed to be an n, whose domain are angles. So what do we mean by this? Well, tangent, it's a function which we can only input values which represent angles. And what exactly are some angles in this figure? Well, let's call this triangle ABC. So this is a function that if we plug in angle A, is going to give us an output. And what output does it give me if I plug in angle of A? Well, tangent, it's always going to be defined as opposite over adjacent. And what do we mean by opposite over adjacent? Well, first, notice that right now we're taking a look at the tangent of angle A. So let's locate where A is located at. So this is my angle A. And the side that is opposite to A, which in this case is CB, that's what we call the opposite leg in relation to angle A. And notice that since this is a right triangle, then therefore this must be my hypotenuse. And the side that is adjacent or next to A is what we refer to as the adjacent. So this is how we're going to be defining tangent, the tangent of an angle. Okay? But let's actually take the tangent of some figures in this right triangle. So let's try to find what happens when we plug in the tangent of A. So if this is my A, then what is my opposite? Which in this case, my opposite has a line segment of CV. And what is my adjacent? Well, my adjacent, it's of a value of AB. So this is just a ratio. Tangent, it's a function that you plug in an angle and it gives you an output of a ratio, which is the ratio between the opposite side divided by the adjacent side. Let's put this into practice. Let's use the definition of tangent of A to define two types of tangents, tangent of x and the tangent of y. So let's start by looking at the tangent of x. The first thing that we want to do when we want to find the tangent of x is locate where the angle x is located at. Well, it's right here. So this is my angle x. Now we need to label the triangle taking in consideration angle x as my reference angle. Well, if x is my reference angle, then the side that is of 12, this is the opposite. YZ, it is the side that is opposite to x. Notice the YZ, or YX, I'm sorry, that's my hypotenuse. So therefore, the line segment ZX, it's my adjacent. So notice that at least in terms of x, this is the opposite side of x. Notice that YX is the hypotenuse of the overall triangle, and the adjacent, it's going to be ZX. So there's only three types of sides: opposite, adjacent, and hypotenuse. So now that we have properly labeled our triangle, let's just plug in what is the tangent of x. Well, recall that the tangent of any angle is the opposite over the adjacent. But in relate to x, what is my opposite? My opposite has a value of 12. And my adjacent has a value of 5. So therefore, the tangent of x is just 12 over 5. How is this different if we want to find the tangent of y? Well, not all tangents are equal, and that is because we're taking a look at different angle. But now let's try to define the tangent of y. Okay, first things first, where is y? So y, it's located right here. So now notice that the side that is opposite to y, it is 5. 13 is still my hypotenuse, and therefore 12 must be my adjacent. So now notice that if I take a look at the tangent of a different angle, my result is going to be different, because still tangent is still opposite of adjacent, but the opposite of angle y, it is 5. And the adjacent of angle y, it is 12. So notice that if we take the tangent of a different angle, it can give me a different output, because the tangent of x is 12 over 5. And the tangent of y, it's 5 over 12. So we just got to be careful with what angle are we inputting into our tangent function. So this is just how we define the tangent ratio. But let's come back to the problem that we stated here on the introduction question. Can we use the ratio we defined in the introduction problem and the following triangles? Is it possible for us to say that tangent of A is congruent of the tangent of R? Is it true that we can say that if I take the tangent of A, that's equivalent to the tangent of R? And notice that we have just stated previously is that A is congruent to R. So the question is saying, if I take the tangent of two congruent angles, is the output going to be the same? Well, let's define them. So what is the tangent of A? So the tangent of A, so if this is my A, then little a, it's my opposite, little c is my hypotenuse, and little b is my adjacent. So therefore, the tangent of A, recall that tangent, it's always defined as opposite of adjacent. So therefore, if this is my A, my opposite is little a, and my adjacent is little b. What is the tangent of R? Well, the tangent of R, if this is my R, then little r is my opposite, and my other leg is my adjacent. So therefore, the tangent of R is r over s. So I know that the tangent of a is a over b, and the tangent of r is r over s. So now, if we want to see if they're equal to each other, what we gotta say is, well, is a over b, so this is a question now, is it true that a over b is equivalent to r over s? Because if we show that this is true, then we have just shown that both that both tangents are congruent to each other, or they are the same output. But don't forget that we have said something about this triangle. We have said that these two triangles are similar triangles. So therefore, we can have those proportion ratios. So therefore, b over s is definitely congruent to a over r. Because recall that b divided by s is congruent to a divided by r. And notice that we almost have it. We almost have it. It's just a different order. But how about, I know that this is true due to similarity triangles. So how about we just manipulate this a little bit? How about I multiply by s on both sides? And if I multiply by s on both sides, then now I have that b is equivalent to as over r. Once we have it this, how about if we multiply by 1 over a, or we divide by a? So if we divide by a, this cancels out with this a. And now notice that we have b over a is equivalent to s over r. Are they equivalent? They're not. They're just different order. But that's fine, because if we flip one side, that's equivalent as if we were to flip the other side. And now notice that we have shown that yes, they are equivalent. A over b is equivalent to r over s. So therefore, or my conclusion in here, my conclusion is that, of course, the tangent of A is congruent, or it is equal. I'm sorry, I shouldn't say congruent. It is equal to the tangent of R. So what we have said is the following. If you take the tangent of two different angles, in this case A and R, if those two angles are congruent to each other, then their tangents are going to be the same value. Take the tangent of two equivalent angles, or two congruent angles, then their outputs are going to be equivalent to each other. So let's take a look at a couple more examples. Look at a couple more examples here. Let me just bring this a little bit down. Can we find the value of y? So where is y? Where is the location of y? So y is located right here. So let's see, what do we know? We know that we have an angle of 56. So if I make 56 my reference angle, then notice that y is my opposite. And notice that 32 is my adjacent. So notice that if I use the tangent of an angle, which I know of being opposite over adjacent, let me plug in what I know. So this means that if I take the tangent of the angle of 56, that's going to be equivalent to the side that is opposite, which is y, divided by the side that is adjacent, which is 32. And notice that once we have it this way, we can definitely solve for y. Because if we want to solve for y, we got to let y be by itself. So let's multiply 32 to both sides. That cancels out. So now we have that y, it is equivalent of 32 times the tangent of 56. But what exactly is this? Well, this is something that we can use our graphing calculator. Because here we're taking the tangent of an angle of 56. And then we're going to multiply that by 32. So let's use our graphing calculator here. And here's something that you have to be careful with. When we're working with tangent functions, be sure, and this is very important, so let me just put here on the side, this is very important. Be sure that the calculator is in degree mode. Because notice that we're plugging in an angle of 56, and angles can be represented in degree, or at least this represents 56 degrees, because that's the little circle that we do have here on the top. So therefore, before we plug in anything, let me make sure that my calculator is in degree mode. So I'm going to go with mode, and I'm going to go on the degree. So now that I have it here in degree mode, let me go back and let me actually plug this in. So 32 times the tangent of 56. And what is that equivalent to? Well, that's equivalent to 47. I forgot the number. So that's equivalent to 47.4. Let's just keep it to the nearest 10. So 47.4 centimeters, meters. Notice that the units are not given here, so I'm just going to keep it as a whole, as a number. This is one of those usage that we can give to the tangent functions. We can use the tangent functions to define the value of sides in a triangle, but just not just any triangle. And I guess that's something that I should have put a lot of emphasis on. Tangent can only be applicable if we're working with right triangles. Because notice that every time that we have defined tangent, or every time that we have worked with tangent, every single problem was of a triangle, of a right triangle. So this is something to keep in mind also. Tangent is applicable if we're talking about a right triangle, at least the way that we're looking at it in this lesson. And the purpose of it is to define either sides or angles in a triangle. But this is just one of those ways where we can use tangent to define the side of a triangle. But now if we take a look at example 4, real quick. Notice what we have here. Let me just erase this, but just be careful. Make sure the calculator is in degree mode. So what exactly are we trying to find in example 4? Notice what we're trying to do in example 4. Under example 4, it states, the degree of a road is the ratio of its rise to its run, and is usually given as a decimal or percentage, which is fine. Now here's the question. Find the angle that the road makes with the horizontal if its grade is 4% or 4/10. We note that the figure is not drawn to scale. And I just noted there's a small typo here, because what we're trying to say here is that the row makes with the horizontal if its grade is 4% or 4/100 or 0.04. So what this is trying to say is that every time that I go 4 units up, or every time that I every time that I increase of 4 units, I'm also moving 100 units. So this is just what we mean by a horizontal if its grade is 4%. That is saying that if I increase by 4 units, I'm also moving 100 units. But the most important thing here is just the setup, which let's just assume that this is not given, and we have this following diagram where we have a right triangle, and we know that the rise is represented by 4 and the run is represented by 100. So now the question is, what is angle x? Notice this is a little bit different than previously, because previously we're looking for sides, but now we're looking for the value of an angle. So how can we go about it? Well, still, we can still use the tangent function. But how do we use the tangent function to define angles? Well, again, recall that the tangent of any angle, that's always equal to the opposite over the adjacent. So if we're looking for angle x, we'll notice that the rise is the opposite and the run is the adjacent. So let me just set this up. What we're trying to do now is show that the tangent of angle x, that's equivalent to the opposite of angle x, which in this case is 4, over the adjacent of angle x, which is 100. And notice that what we're trying to find now is the angle of x. So in other words, we need to cancel out the tangent. And the way that we do cancel out the tangent is to multiply by something that we call the inverse function. And the way that we represent the inverse function is the tangent with a little -1 on top of it. So we're going to multiply by something that we call the inverse function. Because any function multiplied by its inverse, it will always cancel out. So in this case, we will have x is equal to the tangent of inverse of 4 over 100. And this is a little bit weird, like right here on the right hand side, because it's not like 4 over 100 is multiplied by the tangent of -1. It's just that we should have put tangent of -1 in the front, but I guess I just didn't leave some space. But when we talk about multiplying by the inverse of it, we're just saying multiply the inverse so the tangent cancels out. So now we know that x is the tangent inverse of this value. And now the question is, what exactly is this? This is an inverse function, and now the output of an inverse function, it will always give you a degree. And what exactly is this degree? Well, this degree is the following. We're going to go on a graphing calculator and notice that right here on top of tangent, we have in yellow, which says tangent and a little -1 on it, which is that's the function that we want to find. So we're going to press second tangent, and now notice that we have the inverse function. And now at this, we're just going to plug in its value, 4 over 100. And that will be equivalent of x being equivalent to 2 let's keep it as to the nearest 10, so 2.3 degrees. Because notice that x represents an angle, so therefore x represents degrees. One thing to think about it when it comes to tangents and inverse functions is that we stated that for a tangent of x, we plug in an angle and it gives you a value. So this is how we have defined tangent of x's. Tangent of x's are saying, look, for any tangent of x, if I plug in an angle, it gives me a value. Well, for the inverse, we plug in a value and it gives you an angle, which is exactly what we were looking for here. Let's just do one more example when it comes to finding angles. Let's just do one more example when it comes to finding angles. So let's take a look at here on task number 3. Can we find angle y? Well, where is y? Y is located right here. So therefore, this is my y. 6.1 is going to be my opposite, and 4 is going to be my adjacent. So therefore, the tangent of y is going to be opposite, which is 6.1, over adjacent, which is 4. And again, what we want to do is trying to find the angle of y. So therefore, I need to multiply by the inverse. That cancels out. So now we know that y is equivalent to the inverse, evaluate as 6.1 over 4. And this is something that we can use our graphing calculator. So let's say 6.1, second tangent 6.1 over 4. And that's equivalent to about 56 degrees.